Welcome to my channel Ajit-teaches. Today going to talk about a very important topic of cryptography, which is your hash collision and key clustering. Lot many times people get confused between these two terms. This can help you in your CSSP, CCSP, and CISA and CISM exam also. These two are considered as vulnerability into the cryptographic process. Key clustering is a vulnerability related to your encryption process, and hash collision is a vulnerability related to hashing process. What is key clustering? Let's understand that. When we talk about encryption, encryption is a process of converting a plain text into ciphertext with the help of key and an algorithm. Key clustering is one of the vulnerabilities in an encryption process. This name or this term is quite a misnomer. Don't consider this as a grouping of two keys. No, it is pretty different from that. What is key clustering? If you see it in the screen, key clustering means when two exact plain texts are encrypted by two different keys, they result in a precise ciphertext. For example, I'm encrypting Ajit and Ajit by two different keys 123, 145. If it results in same ciphertext ABC, then this is called as key clustering. This condition is not desirable. And if you see it an example also, there are two same plain texts. I pass CSSP, I pass CSSP, and we have used two different keys. One started with 342 and second started with 254. In both the cases, the ciphertexts are same. This condition is not desirable. In order to avoid this situation, what we can use initialization vector. These are random number added to the encryption process to ensure that the two plain texts, when encrypted upon by two different keys, doesn't result in a same ciphertext. Now I add, just for simplicity, I'm keeping it very simple. These are called IV. So now when I add IV and encrypt it, so this will result in a different ciphertext. So this is we call as a key clustering. Key clustering is not a desirable situation. So it is again when you encrypt two plain texts with two same plain texts with two different keys, if it results in a same ciphertext, this condition is called key clustering. To avoid this situation, what you can do, you can use IVs. IVs are random numbers which is added to the encryption process to make it more random. Now let's focus on hash collision. Sometimes people get confused between these two terms, key clustering and hash collision, and they are different. How they are different? I tell you. So key clustering means when two same plain texts, when encrypted upon by two different keys, it result in a same ciphertext. In hash collision, when two different plain text like Ajit 123, Ajit 345, when hashed upon by different algorithm, by same hash algorithm, MD5, it result in same hash digest. So when two different plain texts hashed upon by same algorithm, it result in a same hash digest. This condition is called hash collision. Like in key clustering, we were using IV. Here we use salts to reduce the chances of hash collision. So we will add, let's take an example, 4556. This is what we call as salt. So now it will result in a different hash digest. Another thing you need to remember, look, the hashing is what? It's an algorithm which takes variable length data as an input and gives you fixed length digest as an output. The larger the length of digest it creates, lesser it is vulnerable, lesser it is susceptible to or vulnerable to hash collision attack. In simple words, if you have MD5, you have SHA-1, if you have SHA-224, and if you have SHA-256, MD5 is most vulnerable, and SHA-256 is least vulnerable because the larger the length of digest created, the lesser it is vulnerable to hash collision attack. So in a nutshell, what is key clustering? When two same plain text encrypted upon by two different keys result in a same ciphertext. This is called as key clustering. How you can avoid key clustering? By adding IVs, the random numbers added to the encryption process to make it more random and reduce the chance of key clustering. And what is hash collision? When two different plain texts hashed upon by the same algorithm result in the same digest. This is called as hash collision, and you can reduce the chances of hashing by adding solves. Solves are random number added to the hashing process to make it more random to avoid the chances of hash collision. Remember, the larger the length of digest an algorithm produces, the lesser it is vulnerable to hash collision. Hope it helps. Thank you. Happy learning.